Hello, everyone. It's Lightning Talks time, finally.
Hey, everyone.
I'm Christopher Neugebauer. I am coming to you from the unceded land of the Coast Miwok people here in Petaluma, California. Still annoyingly prevented from being on the correct time zone for Lightning Talks. And so, as with last year, I've adjusted the timing of Lightning Talks to my convenience and not yours. Thank you all for joining. This is going to be really exciting. Today, we've got a couple of people joining me on stage. Libby.
Hello, I'm Libby. I am trapped in an apartment in the Ngunnawal country, aka the ACT in Canberra. It is nice to join you, and for a split second, you saw my cat Bobo. Prepare for ultimate chaos. He will probably make appearances every now and then.
And also joining is our friend Patrick, the disembodied clock.
Hi, Patrick, the disembodied clock.
The disembodied clock. Okay, so as is usually the case, we have a bunch of speakers giving 5-minute talks on various topics, which will hopefully be of interest to all of you. We can't really do the finger applause thing that we do when we're all in person, but I will use my trusty yeet button if people go over 5 minutes. So please keep your talks to 5 minutes, everybody who is presenting. Otherwise, yeah, we won't hear everything you have to say. Our first presenter is Tyson Clugg, who is going to be talking about putting Python in all of the files.
Hi, PyCon. In true Lightning Talk spirit, my tool broke 2 minutes ago and I fixed it again. So, yeet all the files. This is a personal project that I started yesterday. Lots of fun. 20 years earlier, well, we used to use PHP, and we used to be able to just insert little bits of code inside a bigger document. It's a really cool trick because it means that you can just write, for example, HTML or PostScript or whatever you want, and then just put code where you need it, which is awesome. Python doesn't really support this. I mean, maybe a good thing, maybe a bad thing, but in my case, I wanted to because I just wanted to stick in date into a PostScript file, but PostScript doesn't support that. So, yeah, PHP was an option, but I don't want to use PHP, and I certainly don't want to be writing lots and lots of Python if it's just inserting the date. So, yeah, like I could write lots of code to do report lab into inject a date into my PostScript output in a PDF, or I could just fix this little thing. So, need more Curlyboi. Let's see, what can we do? The program, all we need to do is use pyyeet. Let's see. So it just takes a file and it turns all of your source content into compiled Python. What sort of compiled Python? Well, it starts in like, just like Python, it creates this module where it just prints everything out. So nice and simple. But then you can put a Curlyboi in there. Woohoo, more Curlyboi. And here we go. We've got a curly brace and 2 snakes. That gets us into just plain Python mode. Spit it out exactly as you saw it. There's also support for echo mode, which just prints whatever you want. So we can see here that I said, oh yeah, assign hello world to some text. And then I told it to use echo mode to output the text. Nice and easy. Well, that means you can do some cool stuff. So you can just use valid Python anywhere in your file. Well, what is this useful for? I was trying to scratch an itch. As I said, I was trying to write some PostScript. Yeah, I know, PostScript. So here it was. It's basically trying to put like a watermark onto a file, and I needed to have the date on there. So here we are. I'm using, let's see, so I'm from datetime, import datetime, and then that's imported. And now all I have to do is say, use echo mode and put the date in. So let's see, does this do what I want it to do? Okay. I run it. Hey, datetime is not defined. Anyway, yes, it did actually run. Broken as always. So other cool things. Let's actually dive into the code a little bit. We've only got a minute and a half left. what have we got? So it's a little state machine. It is actually an encoder, a decoder. So you can use it to decode bytes, and it decodes bytes into Python. It registers its codec. It does some cool stuff. It has a loader to do to bring it into Python land. It has asynchronous I/O, so it actually runs in an async I/O loop, meaning that in future, maybe this could be an async I/O web service-like thing, and I should include it into ASGI. It has some very simple options. So all it does is loads up the
1 minute.
Python module. We've got a minute left. Great. And it runs things. So, yeah, lots of fun. Lets you do things that you otherwise couldn't do and be more immediate in the way that you do stuff. Is there anything else in my slide deck? Yes, I think there is. Only all the things. Well, in theory, you can actually go and put a new Python file and say that the encoding is, let's see, so new file. Well, you know that you can do codecs at the top like this. Coding yeet, which means in theory you could actually put Python code to generate Python code within your Python code. Have fun with that idea. Hit me up in the chat, and I'll publish this on GitHub and give you all some links. Bye.
Thank you, Tyson, for putting Pythons in our Pythons in our Pythons. Up next, we have Daniel, who is going to be talking to us about racing networkx and tackling code complexity.
Hello, everyone. Firstly, I acknowledge the Ngunnawal people, traditional custodians of the land on which I'm presenting, and pay my respects to their elders past and present. I extend that respect to Aboriginal and Torres Strait Islander people here today. In this lightning talk, I'm going to be speeding through a journey I took trying to optimize algorithms in networkx. I'm starting here in my Jupyter notebook so that I can run this cell here. And we'll come back to that later and see how it's doing. First of all, so my talk is racing networkx. So first of all, what is networkx? It's the gateway library to graph analysis in Python, but it doesn't do everything. Time and space limitations make it not very useful sometimes. When playing with large data sets, I still want to be able to calculate graph metrics, but networkx takes too long, runs out of memory, or fails to work for other reasons. As this happens, I always ask myself whether I can figure out how to do it. Let's consider a graph metric. In this case, we're going to look at something called eccentricity. What is eccentricity? The simplest explanation is the shortest distance to the furthest node. For example, if I wanted to calculate the eccentricity of the highlighted circled node in this picture, we need to figure out how far away all the other nodes are. Let's do that by jumping out from that node until we've reached them all. Here we've already started, having jumped out 1 hop. Now we've jumped out 2 hops, and now 3 hops. And finally, after jumping out 4 hops, we've reached every other node in the network. So the circled node would have an eccentricity of 4. This is useful because nodes with low eccentricity will be positioned centrally in the network. Nodes that fall on the outskirts of a network will have a much higher eccentricity because they needed to traverse the entire network in order to reach everyone. By the way, this method of hopping out being demonstrated is an example of breadth-first searching, which is great to use if you don't have a specific destination in mind. If we think about how most graph query languages work, you typically need to start somewhere from somewhere in the network, and nodes with low eccentricity are typically a good place to start. They're more likely to be highly connected or have information passing through them, as opposed to our highly eccentric Mr. Burns node over in the edge. So how does networkx go with calculating eccentricity? Well, for one thing, networkx's eccentricity algorithm doesn't work on digraphs or directed graphs. You can convert it to an undirected graph, but it's not a true reflection of how information is flowing in the network. NetworkX's eccentricity algorithm also doesn't work on disconnected graphs. You can cycle through connected components, but as a personal pet peeve, NetworkX moves this package around every single time it updates. Even accounting for these issues, if the dataset is too big, NetworkX will just run out of memory or take too long. Unfortunately, I'm as stubborn as a mule. Approximations weren't going to cut it either. I wanted to calculate the real thing. The Stanford large network dataset collection is a great place to pull some large networks for benchmarking. So I downloaded a nice big graph and began experimenting. I wrote some code to mimic how information was propagating through the network in a parallel breadth-first search style. You notice here that I'm working with the numeric representation of the graph, the adjacency matrix. The rows and columns of the adjacency matrix reflect each node, and typically the values of the matrix will be 1 if there's a direct connection between the row node and column node, or 0 if there isn't. Sometimes this value will represent the weight of the connection. The IPython magic function timeit is great for overall benchmarking, but prun was invaluable for finding where in the code the bottlenecks were. Prun shows you the number of times functions are called and the times taken per call, and overall how long things take, which is super handy. Other useful tricks include itertools and more itertools. I found that if I'm ever looping through anything, I have a look at those libraries and see if what I'm trying to do is there. Another useful thing I learned was the switch between C contiguous arrays and Fortran contiguous arrays in NumPy. Order C is better for row operations, and order F is better for column operations. Eventually, my approach was faster, but still limited by the space complexity of the big snap graphs. So I got rid of the dense matrix NumPy stuff because that was taking far too much memory, and started working exclusively with SciPy sparse matrices. That helped, but the biggest bottleneck was the matrix dot product multiplication, which is always computationally very expensive. Ultimately, I had to do with matrix algebra altogether and tried replicating it using binary set operations. Initially, I used Python sets, but they still suffered from space limitations because you need to store an additional hash table for lookups. The workaround there was to use bit arrays. Bit arrays are a very space-efficient Boolean collection that could easily represent the graph adjacency matrix. This created some additional overhead in the conversion, but once that was done, my approach could not only run on the large snap dataset, but was faster than other optimized graph algorithm libraries as well. I'll go back to here. Is it finished running? No, it hasn't. It usually takes under 5 minutes, but I'm doing streaming stuff as well. Thanks.
Thanks, Daniel. Up next, we have Jeff, who is going to be taking us through something slightly more relaxing than networks. Go ahead, Jeff.
Thanks so much, Christopher. Yeah, it is something completely different. I want to thank everybody very quickly for a fantastic conference, but I would also like to invite everybody for a moment of Pi contemplation. And apologies for the pun. And really, what I want to do today in 5 minutes is I just want to share something that's helping me through these really unusual times that we've all been sharing. And I will illustrate this through a really, really terrible watercolor and a story. So apologies in advance for the terrible watercolor. But yeah, this little fella here, we're going to call them Susan the Schneck. And Susan the Schneck, circa 2019, was having a pretty happy life, was meeting all sorts of other Schnecks, potentially in person at conferences like this. And then things changed. I'm going to draw your attention to the left to this we'll call it the vibe axis. Vibes were pretty good. Maybe bushfires notwithstanding, vibes were okay in 2019. And we can potentially argue that vibes are pretty awful in now. So essentially, like, Susan got thrown into a little box. And over time, Susan got so caught up with all the things that Susan couldn't do that Susan sort of tied herself into a knot. And you could say that this little axis here, the yellow axis, which is like happiness, you could say that Susan probably was a bit miserable at that point. So the method that I'm going to show you today is it's a method to sort of be aware that, maybe you're tying yourself into knots like Susan. And even if your external vibes, your external factors don't change, if you practice it fairly diligently, you might find yourself getting a lot happier. So let's get away from watercolors and actually get into the exercise. So for the next 2 minutes, we're going to close our eyes and focus on our breath. We're not going to try to control our breath. We're just going to remain aware of our breath. And that means we're going to know when it comes in and out. We might know whether it's hard or whether it's soft, whether it's fast or whether it's slow, whether it's coming through our nose or whether it's coming through our mouth. Really doesn't matter if it's any of these things. It just matters that we're aware of it. And sometimes placing a hand on your stomach so you can feel it rise or fall, that helps. Or even just trying to focus on the area around your nostril. That can sometimes also help as well. And even though 2 minutes is a short time, I guarantee 99% of us, including me, will get distracted. So those are the instructions. I wish you the best of success. And yes, it doesn't matter if the mind will wander. This is natural and expected. What matters is that you bring it back gently without self-reproach. So we're going to do these 2 minutes now. If you want to go and have a look at the slides later, they've got references right at the end. But let's give it a go right now. So 2 minutes starting now.
One minute.
Way to ruin
There we go.
the vibes there with the 1 minute. I mean, I appreciate that it was a little bit toned down, but I was so relaxed.
I was so trying to match the energy in the room. I promise.
1 minute.
Righto. Okay, next we have Tim, who is doing some things with the PyCon AU logo.
All right. So this is sort of something that started at last PyCon, and I put up a sort of a image of this onto Twitter and a short video, and a lot of people have been asking about it, which is sitting over here in the background. So there's a bit of elements of hardware, software, and woodwork involved in this little project. So like I said, I started this at last PyCon, and I managed to get this far. It's been sitting on my desk, sort of annoying me ever since. And a couple of weeks ago, I sort of looked at this and thought, it's about time I actually got onto it and actually made this into something for real. So first step is a little bit of prototyping. I call my first test the SNET egg. This is sort of where I tried out the concept. It's essentially drill a hole, fill it with hot glue, and put a LED inside, and you get this sort of nice output here. This is my second sort of test where we actually made it into a full, what I call a baby snack. And it started to see, we could see the colors sort of starting to blend, and it looks kind of cool. So moving on to the final build. First stage was drilling out or laying out. You can see my sort of marks there where I've laid it out, drilling in all of the positioning, and then putting this through onto a router table to route out the rest of the shape, putting in the LEDs and the hot glue. This is when I ran into my first problem. I ran out of hot glue, which is not a useful thing. It's sort of a bit of a rush there to try and get another lot of it in the middle of a lockdown. But I managed to do that. But it does have some side effects in that you get bubbles and that starting to come through. From that, we move on to wiring, more wiring, crimping before we get to our first test. And we start to see it sort of how it's going to actually look. There was a few sort of other points that start to come out here. The green and red is very bright, and we're going to have to tone those down, and we'll go into exactly how that works next. So the actual hardware, yeah, it's a lot of wiring, and as you expect for these kind of things, where we control every LED. Most of the control is all done with a bunch of shift registers. These ones are particularly nice. They can sync 150 milliamps, which is perfect for running LEDs. They work by having 3 wires coming into them, a data, a clock, and a latch wire. You set a value on the data, pulse the clock, and it will shift the value in. Do that repetitively, and you'll get all of your data in. Finally, pulse the latch. It switches it on to the outputs, and you just, what you want to see comes up on the display. At the moment, it's running with a Raspberry Pi Pico, which is sort of probably my favorite controller at this particular point in time. How we get into the actual brightness control, I was using a technique called BAM, or bit angle modulation. It's a sort of an alternate to PWM that can be implemented efficiently in software. In this particular picture, I have the sort of the green, which is what the waveforms will look like from BAM, and below that is what a traditional PWM waveform would look like. The ratio between the on and off states, and run that at a high enough frequency, and you can control brightness. So MicroPython turned out really, really good in this particular scenario here. Its threading model on the on the Pico, was great in that it would actually use both cores, which meant you can run your animations and your output on separate threads in parallel. Although I did run into some limits here, the speed of MicroPython, it just isn't quite up to it, so I could only run it using 4-bit BAM. Meaning you only got 16 levels of brightness, but that's more than enough. So the final result is this, and hopefully it'll run, which is a bit of an up close. A nice sort of effect that came out of this is that you can kind of see the colors blending as it comes out, which was actually quite a nice sort of side effect of running it through this glue, which was causing it to diffuse nicely. So what's next? I wouldn't mind porting this to a different language just to get a bit more speed out of it. Probably laser cut. We can reuse the controller. Don't run out of glue would be a handy thing to do here. Slides and code. If you want to read more about what BAM is, there. I'd have to also quickly shout out to Jim Massard, who jumped in from MicroPython to help me. Well, actually just listen to me solve my own problems. Thank you.
Oh, thank you for that, Tim. It is cool to see people doing such pretty things with the mascot of this here conference. Up next, we have Matt Cengia, who is going to be talking about what it says on your screen. Make him welcome. Ben.
Hi everyone, my name is Matt. My pronouns are they and them. I'm going to be talking to you about neurodiversity today. I'd like to start by acknowledging the traditional custodians of the land from which I'm presenting, the Wurundjeri people of the Kulin Nation, and pay my respects to their elders past, present, and emerging. So I have autism and ADHD. These are both 2 types of neurodiversity, which refers to the variation in the human brain regarding sociability, learning, attention and mood, and other mental functions. But they're by no means the only 2 types of neurodiversity. I'm recently diagnosed. I'm still learning about my brain. My intent for this talk is to raise awareness, not to claim that I have all of the answers. We have a saying that if you've met one person with autism, you've met one person with autism. We're all different, and these are specifically my experiences. I found a long time ago that I always struggled with timekeeping and timesheets. I'd seemingly lose hours of productivity some days and not know where they went. And it made it really challenging to bill against clients. And so I ended up having to use this app that a colleague wrote, which would literally pop up every 15 minutes to help me remember to timesheet my work and keep track of what I was doing. Timesheets don't really work for me, and I'm trying to find ways to have jobs that don't involve them. So that's one thing to think about for people who are neurodiverse. And so now I know why. It's because I hyperfocus and sometimes experience time blindness. I can focus on things for hours, which is like a next level flow state, where I can get quite upset if I get interrupted or I have to context switch. It means that I can get a lot done, but it also means that there is nothing else outside of this. And it means I can completely lose track of time and forget important things like eating. I also experience executive dysfunction. If things are not interesting, novel, or urgent, they don't get done. This talk was written in the last 2 hours. It hit the urgent checkbox. I struggle with engagement sometimes. I find that I have to watch talks at double time occasionally just to keep engaged with them if I can, unless they're written by Lee Bernanke or Russell Keith McGee, in which case they work just fine. I find that I'm occasionally distracted by environmental factors such as background noises like elevator dings or fluorescent lighting or movements in the periphery. So I often need to use noise cancelling headphones or like work at my home office where I can, close out those distractions and focus properly on my work. I find that different communication styles work differently for me. Instant messages are great for not putting people on the spot, but you can often lose tone with them if you don't take care. Video and audio are great, but because you've got the body language and the tone, but they can be stressful from a timeliness and response perspective if you feel like you're getting put on the spot. Audio can be the worst of both worlds sometimes, so I try to avoid phone calls, for example. One thing that I found works really well are personal user manuals, which are ways that people can literally write a document that says, here is how I work and here is how my brain works. And I've read about workplaces that have implemented these as an optional thing where they're not required, but it's a great way for people to communicate about what works best for them and find accommodations and compromise. So the main takeaways that I've got from this talk are that all of our brains work differently, and even people who aren't neurodiverse require different ways of thinking sometimes. So I'd say be explicit and open and proactive about working with people to accommodate the way they work. As I said, this helps both neurotypical and neurodivergent folks. Stay curious and have empathy for the way people think. And that's all I've got. Here are some references which I will put in the Venulous chat in a second. Thank you very much.
Thank you, Matt. That was a really important talk, and I thank you for giving it. Up next, we have Jens, who is going to be talking about Grassland in Lower Saxony.
Yeah, thank you very much. Why I want to give this talk. Of course, I'd like to get acquainted with the geodata in agriculture and also from those data that are used from administrative bodies, for at least in Lower Saxony. Then I'd like to show you a few basic commands in GeoPandas you need to know if you want to process such data. And of course, you will be eventually able to validate administrative land use statistics so you can check if they are doing a good job or not. First of all, I like to show where the Lower Saxony is. And by the way, yes, it has a horse inside, so it's a running gag of the chat today. And Lower Saxony is located in northern western region of Germany. So it's between Bremen and Hamburg. They are just the neighbors of Lower Saxony. And yes, it's Germany. And yes, it's 3:30 a.m. So if you present those times, you should really know your stuff. So first of all, we import the both needed libraries, pandas and GeoPandas. I have marked the versions over here. And then we have to get the data, of course, because we want to work with data. First of all, we have to understand some conditions to use this data. And if you click on this link, you will be able to download it. Then you can unzip it and you can import them. Be sure to enter this kind of projection because it's the known projection for all administrative data sets containing GPS coordinates. And those 5 lines are the first 5 lines in the entire data set. You can see what kind of land it is. This is grassland and this is cropland. This is just a shortcut. And this is the name of the year where this polygon has been input into your data set. The first shape is just a sanity check how this shape will look like, and let's look not too far away from Lower Saxony. And now I just added the group, the kind of agriculture indicator, and you can see that there something happens in the northern region. And what is happening in the region, you can see over here. There is the grassland, the Greenland over here, that we are interested in. And now we know where the grassland is. And next question is, we want to see the distribution of the land size grouped by the management system. Therefore, pandas does a good job with the description function. And you can see here that the grassland over here is average 2.6 hectares. There are also very tiny patches with less than 1,000 square meter, but also very big one. And this number is equivalent to 300 soccer pitches in FIFA regulation. So it's a very huge one. The last thing I'd like to show, of course, is the sum, the share of each different agricultural systems. So cropland has more than 2/3 of all imported shapes. Then grassland is coming with a bit more than a quarter, and the rest is not that relevant because this does only mean you do not get any money out of the field. And that's for my talk today. I try to not get into sleep. Thank you very much for your attention, and happy Python, happy farming. Thank you.
Thank you, Jens, for that great talk. And yeah, go get some sleep. Go
Yeah.
on. You can go on. Yeah,
well, yeah, it's too.
Okay. Up next, I understand this is a Python conference, yes. But today, Quentin is going to be talking to us about adders.
Yes, I'm assuming I can be heard well. Thank you, Chris. So my talk today is on obfuscational logic, making binary adders where they shouldn't be. A bit about me. My name is Quentin Lovett. I'm a 5th-year mechatronic engineering student at the University of Technology, Sydney. I work for a cardio electrophysiology company, and this is my 8th Python. So what are binary adders? Binary adders are a way of performing addition with binary numbers. So this is the simplest binary adder. This is a 2-bit, so you can do 1 + 1 or 1 + 0. And so this has an exclusive OR gate, which is one or the other, but not both, and an AND gate. So the output of this is a output bit and a carry bit. So 1 + 1 is 0 plus the carry of 1. In binary is 1, 0. So getting a little bit more complicated than that, we here have a full adder. And so this has the carry in bit and then has the display and the carry out. And so in Python, we can do this simply with OR and AND. So if likes cats or likes dogs and likes cats, or if snake or Curlyboi and programs. And looking a bit deeper into this, we have the Python Boolean or binary operators, OR being the pipe, ampersand the AND, and importantly for this one, we have XOR, which is the caret. And so why do I care? Why I care is addition is too easy in Python. So I'm going to just pull up a demo here. So when we're doing this addition in Python, open up the Python interactive shell, get an int of 9, an int of 10, a plus b, and 21. Perfect. Or not. And so when looking at this, I just got to say that I have been doing some funky stuff. Your Python might not be exactly the same as mine, but now for something a little bit different. So we're going to go and we're going to get our, so going to run Python interactive shell again. And we're going to do a basic half adder. So that's our 1 XOR 1. or 1 and 1, and we're going to bit shift the carry bit so that we now have that in the 2s column. So getting a bit more complicated again, we can do a little bit more complicated full adder. We're going to get 9 plus 12, so that's the binary values. We're going to reverse those so that the 0 bit is in the 0 column, and we're just going to type out a little bit of code. It's not too much, but I think you could see that this might be a little bit too much to do every time. If that's a bit too much for you, that you don't want to type out all that every time you want to do any form of addition, we have this, my piece de resistance, the fruits of my labor. Please enter a number, 1, 2, 3, 4 plus 4, 3, 2, 1. 13 bits of binary gates calculated for you. Thank you.
Oh, thanks for that, Quentin. Yeah, and if you want to give a lightning talk next year about another kind of snake, we haven't had any talks about asps at this conference. So, you know, if you know about that, please sign up to give a lightning talk next year. Right now, we have Wytamma, who is going to be talking about finding parasites with pythons.
Hi, everyone. Thanks for having me today. Yeah, so I'm going to give this talk about finding parasites with Python, specifically blood parasites in turtles. This is from a project that I worked on with Ike Steinig in our PhDs. We're both now postdocs at the Doherty Institute, just by coincidence, which is cool. So this is from a project called Autoscope, and basically we wanted to build a robotic microscope so that we could modify existing microscopes to programmatically control the stage, so how it moves around, and the focus knob, and the camera, and basically with the goal to produce digital slides for production for downstream machine learning applications. So this is sort of born out of two memes. My incessant goal to automate everything that takes longer than 5 minutes, and then the fact that if you stare into a microscope for several hours, you basically go blind. So we wanted a way to digitalize this process. So a little bit about these parasites. So this is a freshwater turtle, and they have this blood parasite called hemogregorines. This is a turtle blood cell. This is the nucleus here, and this is the parasite, this hot dog looking thing. And we think they're transmitted by freshwater leeches, but we're not really sure. And basically you take a blood smear and smear out the blood, and then you look under the microscope in that blood smear for these parasites. So I'll give you a couple of seconds to find the parasite in this slide. Okay, I'll give you a hint. There it is. So it can be very difficult to do this. And basically you have to get a good level of parasitemia, like the number of parasites in the blood cell, you have to count around 1,500 cells per slide. So obviously this needs some automation. So how do we go about this? I designed some 3D printed parts to attach to the microscope, and then printed them out. The stage is controlled by stepper motors, so these 28 BYJ48 stepper motors, and basically these can be controlled with a Raspberry Pi and run on the 5-volt power supply of the Raspberry Pi, so you don't need to supply a separate power supply for them, and you just send a signal to the channels of the stepper motor, and you can make it spin in a set number of steps, so you can control how far the motor turns. For the camera, I used OpenCV, the Python interface for that, and a Raspberry Pi 8 megapixel camera that sits on the top of the eyepiece. And so we used OpenCV to extract a region of interest from there that we could then do our processing on. And using the focus knob, you can kind of see it in this slide here. Down the bottom, we're able to do some autofocusing just by looking at the sharpness of the image. So moving through the X plane or the Z plane and looking at how sharp the image is. For the overall architecture for the software, basically there's this autoscope class that has classes for the stage, the focus, and the camera. And this has two functions, an autofocus function that enables you to focus, automatically focus through the plane of the slide, and then auto scan, which basically does this snake-like pattern to produce tiled output. So here's an example of it running. So yeah, you can see the Raspberry Pi, the step motor in the background there. And then this is the slide on the stage.
One minute.
Yep. And then so it's moving along. And so to view the slide, we use this GDL2 slides, and I'll just open this quickly. So here's the slide. So you can zoom in here. You can see it loads. There's a parasite, find another parasite. Just zoom out. So yeah, you can see the slides there. So what's next? To take that data, do some ML so we can automatically use that system to identify the parasites, and then train a model to automatically identify these parasites. And so yeah, this is all open source. The code is on GitHub, and the 3D components are on Thingiverse. Cool, thank you.
Thank you so much. I, for one, am very glad that there is another parasite talk happening at Lightning Talks at PyConline AU. Up next, we have Zach. He has written code in order to write your tests.
Thanks, everyone. I'm joining you from Ngunnawal country in Canberra, and I'm speedrunning a 12-minute live demo in 5 minutes. So let's get started. Hypothesis is a tool for people who don't like writing tests, because coming up with all your test data is boring, so Hypothesis does that for you. I also got bored writing hypothesis tests, so I wrote code to write hypothesis tests so that you don't have to write tests or write tests to save for writing tests. Anyway, you can just tell Hypothesis to write tests for a sort function, and Hypothesis will tell you there is no sort function. If you tell Hypothesis to write a test for the sort end function, it does that. It tells you that there's 3 arguments, here's some default values for them or how to generate it, and then it calls it. But just calling the sort function might not crash because the Python core devs aren't incompetent, so we might want to check that if you sort the result of sorting something, it doesn't make any further changes. You do that just by telling Hypothesis that sorting is idempotent, which it should be. If you want to check something else, you can check that 2 functions are equivalent. And if you want to check that the ast.literalEval function is equivalent to the eval built-in, at least for all source code strings which represent Python literals, you can tell Hypothesis to do that with just 1 convenient line of terminal code, which is great. And it tells you this, and you can see that Hypothesis doesn't realize that the node or string argument is different from the source code argument when they should be the same. So you'd have to edit this, but it's a great start to the test, right? Or if you think about property-based testing means algebraic properties of binary operators like Haskell, Hypothesis can do that too. I'm not sure why you'd want to, but it can, so that's pretty cool. The most useful type, though, are what we call round-trip tests, where you can tell Hypothesis that you want to test for gzip compression, and it will automatically work out that if a module has a compress function and also has a decompress function, if you compress something, then decompressing it should probably give you the same thing back. So that's pretty cool. All you need to do here is tell it that data is a byte string. And that's a great test for gzip compression. Where it gets more complicated, though, is JSON. JSON, it turns out, is terrifyingly complicated. There's so many arguments here that I have no idea about, really. And that's a lie. I do have some idea about them, but I don't have time to go into them now. So I wrote a shorter version of this test just by deleting a whole bunch of arguments and describing JSON data to Hypothesis. The definition of JSON is very simple recursive data. The base case is either none, true or false, a number or a string, or you can have a list of JSON things, or you can have a dictionary. JSON calls this an object, but that's a reserved term in Python. A dictionary where you have string keys and JSON values. And we're just going to tell Hypothesis that, like, whether or not we allow NaN is varied, whether we check for circular things, whether we want ASCII or Unicode output is all variable, and then, like, do we want to sort the keys to the objects? Also varied. So let's see what happens when we run this test. Any guesses?
They're on a 30-second delay, Zach.
Yeah, this is the slow bit.
A while.
It doesn't usually take this long. I guess this is what I get for doing a live demo. Yeah, anyway, let's just cancel that. And it turns out that this fails because the allow NAND argument also disallows infinity because non-finite numbers aren't technically allowed by the JSON spec. And if you have not a number is unequal to itself, so the test fails. So we'll just say that we always allow non-finite numbers, weird default argument name, but there we are. And we'll just assume that's like a special assert that tells hypothesis it's a bad example, that it's equal. If we run this one, hopefully it'll be faster.
One minute.
Thanks, Chris. All right, so this one fails with a really confusing error message. It turns out that a list containing not a number compares equal to itself until you round trip it through JSON. And that's because there's this list equality performance optimization in CPython, where if a list is the other list, it doesn't bother checking whether the elements are equal. And it turns out that it also starts by comparing elements by identity to avoid deeply nested comparisons. Great performance optimization, but it totally breaks in the presence of NAND. So the real fix for this test is just to tell hypothesis that we don't actually want to deal with not a number, because you never want to deal with not a number. It's an awful value. And if we run the final real test, then this one should pass, hopefully within the next 19 seconds. And there we have it. That's hypothesis. You can use it to avoid writing tests and still find bugs. Thank you very much.
I was waiting for that last one with bated breath. I'm glad you finished within the 5 minutes there, Zach. Good job. Okay, up next we have a slight escalation because Riley is going to tell us where the stairs are.
Alrighty, hello PyCon. I gave a talk last year which coincided with the public debut of a package called Staircase, and this is a 5-minute update, a where are they now? And to be fair, who amongst us couldn't sum up the last year in 5 minutes? Firstly though, let's quickly revisit what the package is, and for that I'm going to focus on one use case, which is where we have timestamp data. Now you're a Python audience, so when I say timestamp data, you probably think pandas. So to set the scene, I'm going to perform a monologue from the Pandas website. Timestamp data is the most basic time of time series data that associates values with points in time. For Pandas objects, it means using the points in time. Now those points in time are implemented in Pandas by the timestamp class, and you can model a time series with a datetime index, which is an index of timestamps, and a vector of values. And we commonly assign this to the X and Y axis respectively. But they also have this period class, which represents a particular span of time, like a particular hour or a particular day or a particular week. And there's also this period index, and I'm sure you can guess what that means. Now, if you're pairing a period index with some values and the periods don't overlap each other, then what you have is a step function. So it's a function over a time domain in this case, which is piecewise constant, and it's made up of horizontal lines. But the periods in a period index are all the same size, and they're limited to specific frequencies like hour or day, and so you are constrained in what you can do. But this is where Staircase steps in, pun intended. So it doesn't have those limits. Staircase is for step functions over a time domain, step functions over the real numbers, and assigning values to intervals over a domain rather than single points opens you up to thinking about problems and their solutions and analysis in a different kind of way. Now, there's lots of fun things that you can do with step functions, much of the same things that you can do with ordinary time series or functions in general. You can add them, you can divide them, you can compare them to see which one is bigger than another. You can calculate their mean or median or analyze the distribution of values and so on. And you can convert them to an ordinary time series if you wish by sampling the step function at regular points or aggregating it over a sequence of periods. So, what's new? There was a major release a month ago which saw every part of the library rewritten to use pandas and NumPy under the hood. So it's a lot faster. It has become very closely aligned with pandas stylistically, and there's a lot of features which have analogies in pandas. For example, two of the biggest enhancements in version 2 are slicing and masking. So with slicing, you start with a step function, you cut it up into slices, And then you perform some calculation over the slices and combine the results. And this is analogous to group bys in pandas. The other is masking, which is analogous in pandas to masking. And we all understand what masking is. So for step functions, this means allowing intervals where the step function is undefined or doesn't exist. And this is a great feature to have. For example, I may have a step function which represents the heart rate of a patient over time. Now, if their heart rate never changes, then this step function is a flat line. And let's face it, it probably has a value of 0. But if they're not flatlining, then analyzing the distribution of the values might be an interesting thing to do. And this is very easy with staircase. But maybe I want to exclude the times that the patient is asleep. And that could happen at random times for arbitrary intervals, especially if they're sharing a room in a public hospital. And if I happen to know when the patient was
1
sleeping
minute.
and I knew when they were awake, like some sort of creepy analytical Santa Claus, then it's very easy to mask those intervals of time and ignore them when performing the analysis. So it's a pretty full-featured package. There's always more to be done. One of today's social events is the staircase sprint. It's not really a sprint because it will just go on forever. You can join whenever you like, even tomorrow or the weeks to come. I've put a backlog of tasks, many of which are beginner friendly, in the repository. So if you're wanting to dip your toe in open source contribution and you don't know where to start, then come along and get wet. Thank you.
Thanks for that, Riley. Okay, up next, we have Evan, who is going to be telling us about email, apparently.
Hello. This is the story of my email. This is my email. This is also my email. This one too. Oh, and this one as well. These are all different emails, and they're all my emails. But I only have one email, and that is this email. How are they all my emails? Through the power of plus addressing. You simply take your email address, you add a plus, and your tag, and it will appear in your inbox. And you can even add dots anywhere you want, and they'll all be ignored. And this isn't just for Gmail. It also works for Outlook, Yahoo, ProtonMail, and Fastmail, and many more. Fastmail even supports subdomain addressing, and they're great because they look just like regular email addresses. But why? Well, these tags let you be in control of how you filter your email, regardless of who it's from. And they also let you easily register accounts for the same service without having to make a whole new email, meaning that you can sign up for as many freebies from that website as you want. But more importantly, it means that you can better protect your email from the ever-increasing companies that leak it, letting you know who leaked your email and giving you the option to filter it all to spam. You can even test if your email has been leaked at haveibeenpwned.com. You can see my email is fine, but one day I got a spam email, and sure enough, I confirmed that a dodgy website leaked it. But I don't care because it's not my main email. Lastly, it's also just really funny to just give out your email now. I've heard on multiple occasions, wow, you made an email just for me? Are you sure that's correct? And, oh, I didn't know you work for us. There are 3 things to note though. You will have to come up with some kind of system for generating and remembering these tags. And unfortunately, this has been used in phishing-like scams, like this Netflix one, where attackers could sign up with someone else's similar email address and have the victim think that their own account needed updating when in fact it was the attacker's. And finally, Just like people, not all websites know about this cool trick, which can be a bit annoying at times. So spread the word. If you're a web dev, stop rolling your own email validation. Just use a library instead. And if you're an email dev, implement subdomain addressing. Oh, and one more thing. This is not my email. This is my email. I don't give out my email publicly, and neither should you. That is the best way to protect your privacy. Thank you.
Thanks for that, Evan. I was just about to ask if evan@gmail was your email address, and that would explain why I had a bounce earlier on. But okay, up next we have Apollo. So let's go.
Hello, everyone, and welcome to my gender reveal party, my quantum gender reveal party. Today, I'm going to explain why my gender is a quantum mechanical object, and then we're going to measure it together using a real quantum computer. So some people have a very strong internal sense of their gender, knowing that they're a woman or a man or something else. These genders behave in ways that we're used to, so I like to think of them as the classical genders. Unfortunately, my gender has never been that simple. I've been trying to find a nice label to slap on it for a few years now, and the best I've found is gender void. But even that's not right. Sometimes my gender doesn't feel like a void at all. Sometimes I'm a soft guy. Sometimes a screaming magpie coming for your helmet. Before I worked as a tech consultant, I studied theoretical physics, and there I discovered the wonderful world of quantum and my gender. So what does it mean to be quantum? Quantum mechanics is just a model we use in physics to describe really small things like atoms. But there's no reason it couldn't apply to bigger things too. Fundamentally, something is quantum mechanical when it displays strange behaviors like superposition and entanglement. Unfortunately, I only have time to talk about superposition for now, but feel free to ask about entanglement later. So superposition means you can be in multiple states at once, kind of. It's classically explained using Schrodinger's cat, where his abused cat is in a superposition of being alive and dead until you open the box and measure the cat. But really, a better way to think of it is that your state is blurred across multiple values, with different likelihoods of a particular state being measured. This blurry probability blob is called a wave function. Now, that sounds just like my gender. I'm blurred across these states, a probability distribution across genders. It's important to note that when a classical object interacts with a quantum object, the wave function collapses to a classical value, like when someone calls me sir or ma'am. So now we're going to do something similar. I'm going to construct an actual quantum state on a real quantum computer, and then we're going to measure that quantum state, which will collapse it into a classical value. And to do so, I'm going to be using Qiskit, which is an open source library, and IBM's free web UI to visually look at what's going on in the code. So what's happening here is on the right, we have the Qiskit code, and on the left, we have a visualization of the quantum circuit, and then a visualization of the quantum state down the bottom. This quantum state is 1 qubit, which is just an atom that's been prepared in a fancy way so that it can only be in 2 states, on or off. So I said earlier that my gender is like a superposition. So what I'm going to do today is I'm going to put that qubit in a 50-50 superposition of on and off. Although on and off aren't very good genders, are they? I guess we should label them something else. I guess the traditional choice here would be male and female, but I'd like to go with something a bit spicier. The true, original binary, the 2 genders fundamentally opposed from each other. I'm talking, of course, about pineapple and pizza. So what we're going to do next is we're going to measure our qubit, which is in a 50-50 superposition of pineapple and pizza, And this is just a simulated outcome down here. And then we can run it on a quantum computer over here. Now, unfortunately, because this is a free and open service, there's a lot of other people trying to use these quantum computers, which means you can wait several hours for your measurement to be run. But I thought of this in advance, and I ran the job earlier this morning. So we have a result here that I haven't looked at yet. So just to quickly rehash over what we've done, I set up a qubit in a 50-50 superposition of pineapple and pizza, and then I just measured that qubit to see which gender it is. And now we're going to find out. This is a very tense moment. Here's our histogram down here. My gender is pineapple. Yay! Thanks for coming, everyone. My name is Apollo. My pronouns are they, them, and my gender is pineapple.
Thanks, Apollo. Right, just waiting for Patrick to get themselves together. There we are. Okay, yep. You had an uncertain amount of time for your talk just then, Apollo, while Patrick had a slight moment. Okay, up next we have David, who is going to tell us about Git.
Right. Hi, I'm Davo. Here are n Git commands you didn't know about. Diff3 merge conflict style. This adds a section to merge conflicts with a common ancestor, so you can actually see what's changed since you last branched. Here is an example from my Talon voice coding config. The default diff algorithm can produce unreadable diff sometimes, but we have others. The patience algorithm tries to keep sequences together, much like the card game which you might otherwise know as Solitaire. But my explanation doesn't really do it justice, so see James Coughlin's blog post, which I've linked there. It is also sometimes slow, but there is also the histogram algorithm, which is based on the patience algorithm, and it's been benchmarked to be faster than the other three diff algorithms in Git. You can color moved lines that have moved in Git diff. Here, you can see chunks of lines that have moved in different colors in my Vim config. Ever forget what A and B refer to when you run git diff? Well, you can change those so that they give you context. Here we have I for index, W for working tree, but you can also have C for commit. Has your editor Git integration failed in a merge conflict? Try Git merge tool. This opens interactive three-way diff tools that you have installed. Here are a few examples that I've used, and you can also use a diff tool instead of staring at git diff to open these same tools. Interactive rebase is great. You can chop and change your history however you want. Here's an example listing you get when you run rebase-i. However, you might not need interactive rebase. Git rebase auto squash will find formatted commit messages generated by the fixup and squash options to git commit. These do the same thing as the actions of the same name in rebase-i. And you also have the amend option to fix up as well, which is basically fix up and reword, much like git commit --amend. Have you ever balked a rebase? Don't worry, Git makes it really hard to lose commits. Git appends to a log whenever something happens. You can view this with git ref log, or you can refer to entries in this log using syntax wherever you can use a commit hash. You can count from the most recent, or you can specify dates as well. This defaults to head, which is what you've checked out as well if you don't specify a branch name. See Dang It Git for more oh no tips. Thank you. Here's a link to my slides. Also, Canva is hiring.
Thanks for that, Davo. Up next, we have Paul, who only received his acceptance at the last minute. I apologize for my email configuration being terrible. Let's go.
Hello, yeah. So hopefully you can see that slide. So this is a link to an Electrek article. It says Tesla is collecting insane amounts of data from its full self-driving test fleet, but in fact it's also collecting video data from its normal fleet, which numbers about 1 million cars. What happens is, to explain things, I have skin in the game. I actually own a Tesla Model 3, so I'm following this basically all the time to see exactly what's going on. But what happens is that the Tesla cars have a certain level of automation, either called autopilot or full self-driving, and within that, they have a training setup with neural networks that they're continually training on the next version of software. And whenever they get to a point where they are have some misbehavior that they're trying to cure, they do something called querying the fleet. They actually ask the fleet to send video data back to the mothership in order for that to be incorporated into the next neural net. Yay for neural networks and machine learning. The problem with that is that that data could potentially be used either to identify people or at least identify cars, or possibly just probe into areas which are restricted. In other words, there's definitely an issue surrounding privacy. And every time I've queried this privacy issue, basically on YouTube, I'm staring into the void as to what it is that's actually being done about it. So a number of things could happen to alleviate it to some extent, like, for example, having data centers in different countries so you don't ship video data off to somewhere else. But I think the ultimate cure would be to have the neural network in each car be able to respond to queries for video data in such a way as it obfuscates anything which could be used to identify people, such as people's faces, or license plate numbers, or any of that sort of thing. But so far, I haven't seen anybody refer to this as a problem specifically with Tesla. I have, though, seen some research in terms of the intersection between data privacy and video data for training data in neural networks. So if anybody has any leads on who is doing that sort of research in Australia or elsewhere even, please hit me up at paul.leopardi@gmail.com. And that's it. Thanks very much.
Thanks for that, Paul. Always appreciate hearing about Teslas from Tesla owners. Up next, we have Peter, who is going to be asking us a very, very vital question.
Thank you very much, Chris. Hi, everyone. I'm Peter, and this is my alarm clock. Now, unfortunately, in order to give this lightning talk, I had to unplug my alarm clock and plug it in near my computer, which means it's lost the time. So my important question is, can you please help me to set the time on my alarm clock? I'm sure that between me and several hundred of the most tech knowledgeable people in the world will be able to work this out. So I'll give you a quick rundown. There's 7 buttons, so that should be pretty easy to work out what everyone does. They are labeled off/FM/AM, min/down, AL1/vol-, snooze/sleep, AL2/vol+, hour/up, and time/M+. Now, I'm sure that's going to be really easy to configure. So whenever I try and do something, please just like shout out what you think the button I should press is, and if you get it right, you can feel smart. So let's start by setting the time. So I've done this before on other clocks, so I know that to set the time, you press the time button first. So let's press the time button. Hey, it stopped flashing, so it's done something. Let's try the hour button or the minute button. Let's go hour, no, hour, minute, no. Hour and minute didn't do anything. I'm going to try the time button again. Let's see what happens. Time, nothing. Hour, nothing. Minute, nothing. All right, if you guessed do a long press of the time button, hey, it started flashing. Now I'm going to be able to do something. All right, long press of the time button was, oh, it stopped flashing. All right, minute, no. Hour, no. All right, long press of the time button. Is it working? Oh, long press. Hey, there we go. Started flashing. Press minutes straight away. Hour straight away. Hey, it works. All right. The time is now 1:14. I don't make the rules. If you don't believe me, check my clock. So now that we have the time set, we're going to try and tune the radio. So I have off/FM/AM. So I'm going to try and put us into FM. Let's see what happens. FM. We have a frequency. Oh, we have static. Let's try up to tune it. Oh, all right. I'm doing a long press to see if it'll automatically tune and I don't have to try and guess what frequency I want. Let's see. Do we have a station?
To listen to.
Hey, we do. All right, let's turn it off now. There's an off button. I'm pressing it, and it set me to AM. Well, it is off/FM/AM, so let's try it again to get to off. Took me back to FM. All right, if your guess was do a long press of the off button, you got it correct. Congratulations. All right, we have the time set. We have the radio set. Now we are going to set the alarm. So I'm going to press the alarm one. A little light came on. I'm going to press it again because I want a radio alarm. And I'm going to set it for 1 minute and I think we'll go for, I can't remember what time it said on my clock. I should have checked. Let's go for 11 past and see if that looks right. Oh, the current time is 15 past. All right, let's change that to 16 past so that it actually goes off while the lightning talk is happening. There we go. We have an alarm set for 16 past. So, hey, good. I've got 1:30, so that'll probably go off with enough time to spare. So I got this alarm clock a few years back because I really wanted one that had red-colored numbers on it, because I've heard that having red lights in your bedroom is less disruptive for your sleep than having any other color. And I've got to say, it certainly has red lights, and I really wish I'd just actually tried out all the buttons to see how to program it first, because this thing has been confusing. Hey, the alarm came off. This is great. It showed me the frequency. Let's turn it off now. I remember how to do that. It's a long press of the
1 minute.
I'm just going to hold that down, and we are going to see that the alarm has turned off. And, oh, it stayed off. All right, that's a surprise. I spent like an hour trying to work out how to make this thing not always work because it's extremely unreliable. Sometimes when you do a long press of the off button, it turns off and then turns on again, and I get really confused. But we got there in the end. So, back to me. Thank you very much for helping me set my clock. I hope you had an easy time of setting the time, tuning the radio, and setting the alarm. The lesson here is, if you are ever trying to design a user interface for something, please do a test of your user interface. Get your actual users to try it out, see what they think, and ask them, when you have just woken up, do you want to see the frequency of the station you've tuned to, or do you care about the time? I'm not sure. Ask your users. Thank you very much, Chris and Libby.
Thanks for that, Peter. I did end up yanking my earpiece out of my ear when that AM static came on. It was the most painful lightning talk I've experienced at this point, but nothing like the pain of actually trying to set that thing.
Yeah, I'm glad that there was a very good lesson at the end of this, because otherwise it was just going to be 5 minutes of, let me show you this incredibly cursed clock, which I mean is also entertaining in and of its own right. So anyway, next up we have Caitlin McLeod, who is going to teach us some lessons about speedrunning. When they were working on this talk, we were chatting in the Discord, and they mentioned to me, wait, Libby, I can't swear in these lightning talks, to which I responded, and they said, Libby, this is suddenly very difficult.
I did say the F word when I said that.
Time starts.
All right, time starts. Hello, I'm Kate Alade, Caitlin. I use she or they pronouns, both are good. Today we're having speedrun lessons. Hello. If you haven't played Celeste before, this is a game about an anxious trans girl called Madeline who finds an ancient abandoned cursed mountain and wins. So some of the lessons that I've learned while speedrunning this game for the past 5 months are as follows. What? Heck? Okay. Great start. Oh no. Oh no. The first one that I want to really talk about is to be honest about what drives you. So myself, I'm a very people and community focused person. But there are a lot of people in speedrunning who are very competitive, and they just want to get better at the game, and they want to show off how cool they are, and they want to beat their friends. That's not always sustainable. There's a lot of people who burn out because they just can't beat the people who are very good at the game. But there's also a lot of people who've stayed in there for a long time, so that's pretty nice. Just gonna get past the screen. There we go. The other big one that I really love about Celeste is, and about Python as well, is how welcoming communities really bring in fresh blood. You don't really think about it when you're involved in these communities for so long, but compared to other speedrunning communities, and especially, Celeste is really friendly. When I started playing on Twitch, and when other people started speedrunning on Twitch before I did, speedrunners just hang out in new speedrunners chats and tell them like cool strats, and it's really cute. In Python, we've got a lot of good. Oh, I'm quite nervous. I'm messing up a lot. We've got a lot of good ways to get new people into the community, and the best thing about that is that even though people are burning out and like moving out into other areas, they've got fresh people coming in and playing with new strats and coming up with new ideas about how to save time in the game, and that's really good. It's really healthy to have that kind of community, and I'm really glad that we've got that. The next lesson that we have is practice, practice, and practice some more. Oh, my cat really wants to leave the room. Okay, you can't. In Celeste, like, a lot of this is muscle memory, right? You really need to get it into your muscle memory. You really need to learn the strats and learn to get better at the game. And if you're... I'm sorry if my camera goes out. He's just nudged the cable. Oh, really, Mickey? If you are burnt out from practicing the same level again and again and again, or you're burnt out from only having one focus at work and in your programming things, it's good to try and practice something else. There are other categories, there are other tools. You could give machine learning a try, for example, in Python. They're all options that you've got. So just, yeah, have an eye on it. Practice is really good, and it's really good to be able to spend time on the things that you love, but also, there we go. You really want to keep an eye on your, like, how you're feeling about the thing. If it's feeling like a drag, then you're not going to be as effective at it. And obviously Celeste is a video game, right? Like, it's designed to be fun. Instead of a chore or something that you heck me. Thank you. Okay. Something that you necessarily do for money. But that can be it. Another thing that I've really loved about Celeste is how generous the community is. Not just with their time, but also with their money. There's a lot of speedrunning marathons that raise a lot of cash for important charities like Trans Lifeline, Trans Liberation.
1 minute.
1 minute. Oh, that's fine. We might finish the level. We might not. I did mess up a bit. Ooh. Just gonna focus for this screen. Oh, no. But also collaboration has been really important in this community. I was part of a Celeste speedrunning tournament, which had really impressive technical capabilities for restreaming so many different people and recording their runs and their races. We're gonna finish. The most important speedrunning tip that I've got for you all, however, is to just fast bubble every single bubble so that you don't lose your speed. Thank you very much. That was a 407 within 6 seconds of my PB. That's pretty good. And I just want to get to this part of the cutscene. And this is Theo falling down from a cliff.
9.
We nailed it. Thank you very much.
Okay, thank you for that, Caitlin. Hey, it's time for our last lightning talk. After Caitlin interrupted our stream of Peter and Paul, we've now got Marius, who's going to be telling us about something extremely important with TensorFlow.
Yeah, hi. I'm coming to you from Darug country in southwest Sydney today. And I was just going to talk people through my latest, weekend project. My weekend projects never take a weekend; they're always a bit longer. But basically, this was the idea of generating metal band names using machine learning. So using Python and TensorFlow. So I'm a data scientist at work and a metal fan at home. And I thought metal band names were kind of a fun thing to play around with some kind of data science tools. Because if you're a fan of the genre, you sort of know that there's kind of some correlation between band names and all these hyper-specific subgenres that people use, like atmospheric black metal. But it's not really easy to pin down. So it's sort of fun to play around in that space and see if you can kind of approximate that kind of fuzzy feeling of how some band names are sort of suited to some certain genres. So I think, Blood Incantation, great death metal band name. They love these 4-syllable words. But yeah, some of the other things are a little bit harder to pin down. You can't necessarily spell out rules for why bands are called certain things. You just sort of know it when you see them. Yeah, so it's kind of a complex input space with some kind of structure or correlation to it. There's lots of labeled examples to it because there's obsessive people on the internet cataloging all these bands and listing all their genres. You can check that the generative model you're using is working based on kind of the vibe, and the wrong answers are funny. Yeah, and obviously, even if your machine learning model goes really wrong, you're probably not going to come up with this. They are a genuinely good band, but the name is kind of intentionally unpronounceable. Yeah, so for my weekend projects, in order to actually get them done, I try to keep them simple and just, use what's already out there rather than trying to do everything from scratch. So in this project, there's scraping the Encyclopedia Metallum. You can use Scrapi or requests or whatever else. I think what ended up working was just doing requests. It's really not a dev-friendly site. It has no particularly nice API. I sort of had to look at scripts people had already written and modify them a bit. And it was a bit of a nightmare. And then, yeah, you've got NumPy, Pandas, JupyterLab, your kind of standard data science stack for going through the initial data and kind of figuring out what's there. And then what really helped get this off the ground is someone's written this Python package called TextGenRNN. And what it has is it has pre-trained text generation models that have already been trained on huge batches of text. So they sort of already know how text works. Yeah, and training ML models from scratch is not always fun. It's not necessarily something you want to be doing on your weekends. And this gives you a really good base to start from. And then the other thing that helped was I wanted to put this up on the web so people could actually see it. And it turns out TensorFlow models are pretty easy to transfer from Python once you've trained them up and import them into tensorflow.js where they can run in the browser. So what I actually ended up with for a machine learning model that generates metal band names, it's mostly just using TextGenRNN's model architecture. So it's a recurrent neural network using long short-term memory for the band names. And then in order to kind of add in this extra wrinkle of genre information, we're feeding that in as kind of a vector of binary values for each band. Each band can have multiple different genres. And that required some slight modification of the TextGen model. But that's sort of really what I really wanted to focus on. So it's trained on all the bands that were available in the Encyclopedia Metallum, and it only needed 5 training epochs to get good results. It's up on the web. That was relatively easy to do, although I'm not great at JavaScript. And what you end up with is some code that generates potentially offensive names, so I'm not going to run it live. But you should try it out for yourself, and it comes up with all these fun names like this. Yeah, so that is playing around with generative ML models at home, and it's something I'd encourage people to check out. And thank you.
Oh, thank you, Marius. Okay, well, that is all of the lightning talks that we have this year. I'm as sad as all of you are as well. Oh, hi, Bobo.
Yeah. Hi. I all know what you're here for. Hey, 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 what's this? What's this? What's this? Over here, over here, over here, over here. Oh my god, you're adult. It's right that you were looking at it.
It's everyone's favorite treat-ignoring horse. Right, so yeah, that brings us to the end of the lightning talks for this year. I'm sad. I'm sure you're all sad as well, but you've got a whole year, hopefully not spent in lockdown, to come up with your next idea for lightning talks, which you can present at next year's PyCon AU, wherever that ends up being, either where you are right now or online. As usual, I would love to thank the great AV crew who make this thing work, including Ryan, who has been backstage for the entire thing and won't let me bring him on stage. Jack, who has been doing all the tech checks to make sure that people actually join StreamYard without things breaking. And of course, Patrick, the disembodied clock.
Thank you, disembodied clock.
And of course, thanks to Libby Berrie, who has been wrangling all of the speakers, as well as Bobo, for today's lightning talks.
He helps. And
Is that what's
tries to
going on
eat
right
my
now?
hand. Oh, yeah.
Yeah, that is definitely helping. Okay, so yeah, thank you, Libby, and thank you to all of our presenters. I love these lightning talks at every PyCon AU, and I'm really looking forward to seeing what you all have next year. See you then, and maybe see you in Mario Kart in a bit if you're all playing. Hey, bye everyone.
Heck yeah. All right, take care, everyone. Stay safe.
I presume we're
How
off
long
now.
are we waving for?
Are we off?
I have no idea.
Tell us about
Hey,
horses.
Bobo. Hey, Bobo, do you want to attack the dead cat again? That was a lot of fun. Do it.
Great,
Do it,
thanks,
do it, do it.
Patrick.